Hello, this is section 5.6, and we're going to solve logarithmic and exponential equations. So we're going to take our knowledge about logarithms and exponents and be able to solve different types of equations. So let's look at this one. This one, I can see that it's a log, base 2 with an argument of 3x minus 4. And on the right side, there's not a log, it's just 5. So because it's just a simple logarithm, we can say, all right, don't know how to solve it as a log, but what if I rewrite it as an exponent? So 2 to the 5th power, right? And the argument becomes the answer. So we're just rewriting it from a logarithmic equation to an exponential equation. Then we're here, like, what do we do next? Well, what can we simplify? Can I figure that out? 2 times 2 times 2 times 2 times 2, which is 35. Sorry, 32. Did not mean to say that. You can use a calculator if you need to do that. And then 3x minus 4. Once you get to here, it's just a regular equation. Regular, nice, linear equation. And that's the power of logarithms. One of the many things you can do. There we are. Okay. So let's look at these two problems. So you can see that I have logs on the left and no logs on the right. However, there's 2 logs on the left. And before I can write it in exponential form, it has to be 1 log on the left. So is there a way that I can condense it to 1 log? Aha. You're like, oh, the properties. That's right. So it's addition. They're both base 5. So I'm going to rewrite this. X, and yes, you're going to put the parentheses, and 1. All right, now I'm going to rewrite it as an exponential equation. Okay, you're like, oh, okay, but we know how to do this. We've done this. I'm going to write it up here. So I'm going to have 5, and I'm going to multiply that out. So it's going to be x squared. 6x plus 2x is going to get 8x. Plus 12. Now, don't forget, when we get to here, this is not a linear equation. You're not going to move the 12. No. Remember, this is squared. You want it to equal a 0. So you're going to subtract 5 to both sides. Here we are. And then we're going to factor. Remember, quadratic factor. Factors are 7 to 7 and 1, and then plus plus. Okay, that looks funny. Sorry about that. So it's x equals -1 and x equals 7. Or sorry, -7. So here, I didn't test the other one, but we need to test every time. So remember, the argument always has to be positive. So I'm going to take this number, -1, I'm going to put in here. So -1 plus 6, that's going to be a positive 5. That's great. -1 plus 2, that's going to be positive 1. So this is good. -7. -7 plus 6, that gives me a -1. Can't have an argument that's negative, therefore that's not a solution. All right, so let's do the next one. So if we're looking at this one, now I have subtraction. So again, I have 2 logs on the left, none on the right. So subtraction is division. So I'm going to use the same base, so it's 4. X squared, condensing into 1 single log. So then I'm going to rewrite it. Exponential equation. There you are. Okay, then we have to solve. So here I'm going to simplify. That's going to be 64. And then someone's going to say, oh, we have to do long division. No. Before you attempt that, can I factor that? Yes. Yes, I can, right? So that's an x plus 3 and an x minus 3 because it's special. Perfect square with a minus, so x plus 3. Oh, and see how nice that turned out? So this will simplify out to 1. So before you try to do long division, see if there's a shortcut or an easier way to do it. Then you can just add 3 to both sides, and your answer is 67. Okay, let's test this. So if I put 67 to here, you square it, minus sign, it's going to be positive. 67 of positive plus a positive is going to give me positive, so we're good. Right? All right, so same base property of logs. Now this is different, these types of equations, because if you're looking here, you can see there's a log on the left and a log on the right of the equal sign. And the base is the same. So if you have a log, single log on each side of the equation, then the argument here are equal to each other. So that's similar with exponential functions with same base there. The bases are the same, then the exponents are equal here. If the bases are the same, then the arguments are equal. So let's look at this example. So I have the base 7, and they're both a log on both sides, a single log. Therefore, the arguments are equal. Ta-da! All right. So we're looking at these two problems. Before you can use the same base, it has to be one single log on both sides. So over here, I have something in front of the log, and I don't want that. So how do I move it? Well, remember our property. We can power up, and we can put it here. So I'm going to rewrite it. Okay, now that we have the same base, log on either end, single log on both sides of the equal sign, we're going to set the arguments equal, take the square root, so x equals 7 and negative 7. So if I put in positive 7, is it good? Perfect. What if I put in a negative 7? No, then it's negative and I don't want that. So my answer is just x equals 7. Okay. So this one, again, I have a log, but I have 2 logs on the left side. So we need to condense to 1. And then I do have a log here on the right side. Okay, so this is addition. So I'm going to remember the product property, and I'm going to rewrite it as multiplication. Okay, now that they're both a single log on either side of the equal sign, now I can set them equal. Okay, and I'm going to multiply that out by distributing. Okay, remember, this is a quadratic, so it has to equal 0. Not 10. Subtract that. Okay, I'm looking at here, and as I was doing the problem, I realized there's a factor of 5. So I'm going to take that out, hoping that that will make our life easier when we factor. Oh, and it does. So what are the factors of 2? 2 and 1. And it's plus and minus, so I know one of them has to be positive, the other one's a negative. So the larger number 2 has to have the same sign as the middle. So my answer is x equals negative 2 and x equals positive 1. I'm going to check it again. Negative 2 goes into here, that'd be negative 10, not possible. Put 1 into here, that's 5, that's positive 5. And then check this one as well. 1 plus 1 is 2. That's good. Okay. All right, solving exponential equations using logs. So you can see this is not a logarithmic equation, it's exponential. But do we know what the answer is? Well, let's see. 7 to what power is 159? Well, 7 to the second power is 49. 7 to the third power, let's see, it's 343. So somewhere in between there. But I don't know what that is. What do we do? This is where logarithms come into play. So it's like you can take a square root of anything, right, on both sides at any time. You can do that with logs. So I'm going to take the log of both sides. Yep, you just write log. Right? Here's really the power of logs, right? If you've taken a problem that it's exponential, didn't see log, but now I can. If it's an exponential, because they're inverses, you can do this. Because the reason why we want to do this for exponential, because of this. It's hard when the exponent is a variable. So using this, right, the power down property, or that power property of logs, you can bring that down. That's very powerful. Okay. So you take logs both sides. Now, once you do here, this is multiplication, and the inverse of multiplication is division. And this is our answer. This is our exact answer. Now, if we want an approximation, you're going to use a calculator, just like we did with the change of base formula, which kind of looks like that, right? Similar. Right, so the answer is 2.6049. And that's what we were thinking in the beginning, right? Between 2 and 3. Excellent. All right, so these problems can be a little bit more difficult, and all the problems will be different, so you just have to take it as they come. So if I'm looking at this again, what do I know? It's an exponential, and I want that variable to get it down. So I'm going to take the log of both sides. So I'm going to take this and power down. Now, when you do that, don't forget to put the parentheses. That is important. Okay. And then we're going to divide the log of 8. Sorry, log of 8. And then one last thing you have to add 2 to both sides. Okay. So this is the exact answer. Again, if I want an estimation, I'm going to use my calculator. Now, as I'm doing this, please note, instead of the common log base 10, we could have also done natural log, and the answer would be the same. I'm going to circle all of that. Okay. This one's going to be a little bit more tricky. This next one. The reason why, because there's a variable on both sides. So, but same thing, because it's an exponential, I'm going to log both sides. And when I do that using the power property, I'm going to power down. Now I'm going to put the parentheses. Again, good habits in your math. Don't get lazy. These symbols are important. Now, because there's an x on both sides, I'm going to have to distribute this side. And things are going to get very messy very quickly. So, now class, if you do use a natural log, that's fine. That's what you were taught before, and you're comfortable with that. So now I have to combine our x's here and here. So I'm going to move this one to the other side by adding it. And we're doing this because I want the x's on both sides so I can factor it out, making 1x. Now note that I put the numbers in front. We do not put the numbers in back, because then it would look like a log of 125. So now that we have this, I'm going to factor out my x. Then I'm going to divide this to both sides. Okay. And I'm going to estimate that as well. Now, when you do this, please make sure for your calculator you put a parentheses around that, or you will not get the right answer. And if you're working with a friend or comparing it with me or someone else, and you're like, oh my gosh, we have different answers, and I keep getting a different answer, double check your parentheses, close parentheses. Okay. All right, I have 1.7625. Yes, okay. Gonna all of that there. So we learned different ways to solve equations depending on what you're given. To really look at your problem. So here are 3 problems you have to do on your own. Really look at them. Really decide which one of the 3 types of problems that we did earlier do they match with, right? And I will say this for B and C. Look, there's a log on both sides, and over here, there's only log on the left side, but not here. So really look at your notes to review them. All right, so these problems are for you to do on your own. And when you're done, don't forget to answer the EQ. Thanks for watching. Ciao.